What is Enigma, how does it work, and what opportunities does it present by Cryptonetworks.wiki. What is Enigma? Enigma is a crypto network that processes blockchain data in a private way. Enigma allows groups and individuals to store and run computations on data without anybody else having access. An optimized type of secure multi-party computation, SMPC, provides the foundation for Enigma. A secret sharing mechanism, which anyone can test, guarantees the SMPC. The network uses a modified distributed hash table to store this secret data. An external blockchain coordinates the network. It manages who can make changes and keeps a record of everybody on the network. It also keeps a record of everything which happens on there. Enigma charges people fees to use its private computation service. It gives these fees to people who do work for the network. This work includes doing the private computation itself. It also includes maintaining correctness and fairness within the system. For this, the network also makes use of deposits. Enigma does not need a trusted third party to function. In this way, it's like Bitcoin. This enables people to build services on their data without losing privacy. Enigma is a crypto network which provides private computation in a decentralized way. The Enigma team wants to make it possible for the developers to build private, decentralized applications. Background. The new decentralized architecture of services built on blockchains is revolutionary. But blockchains need exhaustive verification to function, and all events on them are open for everyone to see. This puts a limit on what we can build with them. Digital services need large quantities of data, and they process very complicated analyses of that data. Many of these services run these processes on private data. Blockchains are not well equipped for this situation. They cannot make events on the blockchain private. This is because blockchain nodes check every piece of data on the network. Neither can they handle difficult computations. They definitely can't handle difficult computations on private data. The result of this is the status quo. Digital services use a very centralized approach. We only trust individual organizations to store and process our private data. The problem is that this has led to dangerous data leaks. It also gives incredible power to central parties to manipulate end users. How Enigma works. First, the user asks the network to process some data. Enigma divides the data across different computers called nodes. No single node sees the whole set of data. This is important for privacy because it means that nobody can see the whole picture. They all have random little bits of the data. The nodes work together to do the computation. Another feature of Enigma is that it's scalable. Only a small number of nodes on the network repeat the same computations. This is in comparison to normal blockchains. With normal blockchains, every node does the same computation. This means that Enigma can do much more difficult computations than a normal blockchain. Enigma can process data without seeing it too. This is the most important new service it provides. Here's an example to make it clearer. Say you and your colleagues want to know what the average salary between you is, but nobody wants to share their individual salary. How would you do that? Enigma can help with this. It's a trivial example, but it makes the idea concrete. In reality, Enigma can do very, very complicated processing on your data. Many different people can input data to the same calculation and receive the result without anybody knowing the other inputs. One big benefit of this kind of private computation is that it enables data holders to decide when to show their data. At the moment, data is either shared or is not. Once you have shared a piece of data, it is out in the wild. Other people can share it in any way they want. Enigma connects to existing blockchains. From there, it downloads private and heavy computation into its own network. These blockchains control which data Enigma downloads. They use digital signatures and programmable permissions to achieve this. Some of the computation happens on the blockchain, some of it on Enigma. The public parts happen on the blockchain, the private and heavy parts on Enigma. When a computation runs, Enigma stores proof that it ran in the right way on the blockchain. Enigma makes a Turing-complete scripting language available for developers. This enables them to create private contracts for their decentralized applications. Private smart contracts can choose whether or not to make their content public. This is different to normal smart contracts, which are public by default. Enigma achieves its scalability advantage by reducing the number of times code runs. Whereas blockchains run code on every node, Enigma only runs it on some nodes. Enigma solves the following issues of blockchain technology. 1. Storage. It's expensive to store data on a blockchain. Enigma solves this using a distributed hash table, a DHT. A blockchain can access references to data on the DHT. Note that it can't access the data itself. Developers encrypt data before they store it. The Enigma scripting language makes this easier for them. 2. Privacy enforcing computation. Private computation is not possible on open, transparent blockchains. Enigma enables data processing without anybody being able to see the data. This is very important in moving away from centralized data services. 3. Heavy processing. Traditional blockchains are not able to process complicated things. The Enigma network takes these processes off the blockchain. This has another benefit of freeing up capacity on the blockchain itself. Enigma's token model. People who contribute to the Enigma network receive rewards. These rewards come from the fees that consumers pay. People running nodes that do the private computation receive tokens for their work. What's stopping these people from doing malicious things, though? They need to provide a security deposit. If found doing bad things, the nodes can lose their deposit. Security deposits. Networks like Enigma can suffer attacks. One attack is when a node learns the result of a computation before the other nodes do. This gives them access to the sensitive output, which is dangerous. There's no technical solution to this problem, but financial incentives can prevent it from happening. Enigma punishes nodes found doing this by slashing their deposits. To take part on Enigma, a node must deposit ENG tokens. After every computation, a private contract checks everything was correct and fair. If the node lies or stops the computation too early, it loses its deposit. This deposit is then divided between the remaining good nodes. The network continues without the bad node. They no longer get to run computations for the network and cannot receive fees. Computation fees. Every action a user takes on Enigma has a cost. Users pay in ENG coins. The actions include storing data, getting it out, and running processes on the data. This is quite like the idea of gas on the Ethereum network. Enigma is different to Ethereum though. On Ethereum, every node runs every computation. On Enigma, only some nodes run a computation, and different nodes contribute more or less to a computation. So it makes sense that nodes get rewarded according to how much they do. Rounds are the unit of measurement for contributions. Storage fees. Users pay for storage from their account balance. The hosting contract automates this. If the user's balance is too low, they cannot access their data. Enigma deletes the data if storage fees are unpaid for too long. The cost of data storage is set by the market.